Welcome to another event in our series, Medicine and Society. Today our topic is Ethics in the New Genomics. Are we more than our genes? And our special guest today is Dr. Tom Murray, president of the Hastings Center. Tom, we're so happy and excited to have you here. The Hastings Center, after all, is the largest and most well-known bioethics center in the country. We know you've been doing tons of things in Charlotte, and we really appreciate your visit here. We just had a very interesting exchange with you over lunch, where we were talking about genetic screening. When I was growing up, nobody was screened for anything. I mean, I never heard of genetic screening. It wasn't a topic and so on. But nowadays, it seems like everybody's being screened for everything. Parents want to have their embryos and or baby children screened for a variety of genetic conditions. Women who think they're at risk for BRCA1 or BRCA2, the so-called breast cancer genes, are very eager to know that. People who think they are at risk for Huntington's disease, they want to get screened for that. People who have heard they can get screened for diseases such as Alzheimer's disease, they want to get screened too. Now, one of the problems I have about this screening going on is how good is the screening, how accurate it is, because what I worry about is people make major life decisions on the basis of that genetic screening. Some people choose not to go forward with a pregnancy, depending upon what a genetic test says. Some women who find out they have one of those breast cancer genes elects to do a double mastectomy, even though they could control that in another way. Some people who find out they're going to get Huntington's disease, they alter their life balance in very severe sorts of ways. And then some people who find out that they're at risk for conditions, or they think they're at risk for Alzheimer's disease, start to get neurotic and worry, and every time they forget something in the house, they think, oh, here it is. What's your take on this? Is this an issue we should be worried about, all the screening?
Well, genetic information is going to be increasingly available and increasingly important in people's lives. But you're absolutely right that a lot of the genetic information that will be coming it's not clear what use we should make of it or whether we should allow it to influence key life decisions. For example, you mentioned Huntington's disease.
Right.
I suspect for a lot of people, Huntington's disease is the model of a genetic disease. And, well, it is a genetic disease, but it is, if you imagine a continuum of genetic diseases, it's at the absolute far end, in that if you have the mutation, which is a kind of genetic stutter, a repeat of three letters in the DNA alphabet at the end of the gene, if you have a long enough stutter and you live long enough, far as we know, you will develop Huntington's disease, which is a terrible disease.
So you have a sentence there.
It's what scientists would call it deterministic. It's a very deterministic disease, and with a very clear relationship to the gene. If you have the kind of mutation that causes it, you will ultimately develop the disease. If you don't have the mutation, you will not develop the disease. That is completely atypical of most of the connections between genes and diseases. In most cases, the diseases that afflict most of us, that cause the most illness, that cause the most expense, that cause the most grief to individuals and families, are very complex mixtures of many different genes, which are talking to one another, and complex environmental factors. So Huntington's is a model, but it's a very misleading model of the connection between genes and disease for most of us.
Okay, one question I have about that is the test for something like Huntington's disease, that's fairly accurate, isn't it?
Yes.
Whereas, you know, when I hear about these tests, let's say for Alzheimer's disease, I've heard that some of them really aren't so good. or aren't very accurate. Could you tell me more about that?
Sure. I think accuracy here has two meanings. One meaning is, when I get a reading in the test, does it actually tell me what I claim it's telling me? So let's take the breast cancer genes, BRCA1 and BRCA2.
A lot of women worry about that.
Yeah. If you have, we can test for clinically significant mutations in those genes. If we find one, we know that means your lifetime risk of breast cancer rises from the population background rate, which is somewhere around 10 or 11% over the course of a lifetime, to a much higher number. It might be 40 to 60 some percent. Still doesn't mean you're guaranteed to get breast cancer, because anywhere from 1 in 2 or 1 in 3 women who have one of these mutations will never develop breast cancer. So that's the distinction. The distinction is, do we know for sure that you have this gene? And the tests are pretty good at that. I mean, we can actually read bits of your genetic code and say whether you have that or not. But can I go from that to predicting that you're going to develop the disease? In breast cancer, it's significant part of the way. But in many of the other diseases we're going to be, the genetic links to disease we'll be testing for, things about heart disease, autoimmune diseases, and stroke and things like that, the connections are much more tenuous. So I can tell you have the mutation, that part's accurate, but can I tell you what that means for your likelihood of developing disease? It's much tougher.
I think people need to know that and realize it, and that's why I think the role of genetic counseling is so important. Many of the clinicians or the hospitals here have very good genetic counseling programs, but they mentioned that there aren't nearly enough genetic counselors in the U.S. to meet the growing need to have the kinds of discussions that you're saying might be good, to tell people like, hey, just because you have the gene doesn't mean you're going to get the condition. Maybe an environmental trigger has to trigger it in some sort of way. But as I understand it, A, we don't have enough genetic counselors, and maybe you can tell me why. B, genetic counselors in the healthcare insurance packages, it's harder to get reimbursed for talking to people than doing things to people. And C, there's kind of a discussion among genetic counselors themselves about how directive they should be with respect to people or how non-directive. Whether they should tell people, well, if I were you, I might think about such and such, or which they should simply say, here's a lot of data. Go home and think about it and then make a decision. See you later.
Well, we don't have nearly enough genetic counselors in the country.
Yeah.
And we have no prospect of training a large enough
Why
number.
is that? Why don't people want to go into it?
Well, there are lack of training programs, difficulty in getting reimbursed for your services, just what you said about insurance companies aren't keen on paying for talking.
Talking, right.
It's just been difficult to come up with. There are plenty of people who would like to do it. We don't have ways to train them. We don't have the mechanisms by which they can be paid decently for the skill level that they would bring to it. So if we're waiting for enough genetic counselors to be trained, maybe our great-great-great-grandchildren will have enough. We have to do something else in the meantime. And part of it's going to be training our doctors, those in practice right now, and those that are currently being trained, to be useful to you, to help interpret some of the genetic information that's going to come your way. That's one thing we'll do. But the second is we're going to have to take responsibility as individuals for understanding better what the results of these tests mean for us. That's a huge challenge.
Yeah, I think you're absolutely right. There needs to be much more education of the public about exactly what some of these tests or so on mean and whatever. One thing I worry about in terms of genetic testing and screening, and well, actually genetic testing, is direct-to-consumer kits, that might be developed in the future that I can just go home in the privacy of my own bedroom, where you could do pregnancy tests in the old days, but find out if I'm at risk for something. And then basically there's no opportunity for discussion with anybody else. And I might say, I don't want to talk to anyone. It's a matter of me. What do you think of the likelihood of that happening?
Well, the future's here. You don't do the test at home, but you can get a kit and provide the genetic sample, and then they'll give you the results. And there are two flavors of this, and neither of them is at this point particularly attractive.
Okay, what are the flavors? They're not chocolate and vanilla.
Not chocolate and vanilla. Well, one is it's identity testing. Now, one thing you can do with anybody's DNA, and you can do it, quite frankly, the mugs that we're using right now. Yeah. After
I'm not going to drink.
Okay, after this session, I could just get enough DNA off of your mug to do a DNA fingerprint of you.
Yes.
Yes.
That sounds scary.
Well, it can be.
All right.
And it's being used in things like the FBI's database to identify criminals. So, and that's, a use I applaud. I think it's a very good use. Sometimes it identifies a criminal. Sometimes someone who's innocent, the DNA evidence confirms their innocence. So it's useful in improving our pursuit of justice. The most common direct-to-consumer use of that same kind of test, the identity test, is so-called fidelity testing.
Fidelity testing?
Yeah.
It sounds like something the TV shows might want to pick up on.
They probably have. And it's exactly as you'd imagine. Somebody suspects a partner of infidelity. They get a sample and there are different ways to come up with the sample, and they send it to the lab to be tested. So that's direct. You can do that. You go on the web right now. You can find 1-800-Who's the Dad. You can find a variety.
Who's the dad?
Oh yeah, you can find a variety of.
It's paternity testing.
Paternity testing, fidelity testing, biological relationship testing. You can do that. That's one flavor. The second flavor is, and here there aren't so many tests available, but one that we know of is for a gene that no one in the audience is probably going to know, ACTN3, but it's connected with what kind of muscles you have.
Yes.
Whether you have fast twitch muscles that make you better at sprinting and power sports, or whether you have slow twitch muscles making you maybe better at endurance, like the marathon, or running the New York Marathon. You can send with $110 Australian, you can take a sample, send it to Australia, and they will tell you which form of the gene you have.
What kind of muscle you have.
And the actual usefulness of this test in predicting who's going to be a good sprinter or a good distance runner is awfully close to zero. So it's basically a waste
of money. Giving
$110
to Australia.
It's a waste of, it helps the Australian economy, does little or nothing for any of us here.
Oh my gosh. Well, trying to ask you some more questions. When I teach some of my courses, I really love showing this one film called Gattaca. It's sort of sci-fi, but it's almost like it's here today. And it's about a society that basically goes, what should I say, to the excesses of genetic screening and all of this, and is able, through genetic engineering techniques or so on, to help people have so-called perfect babies or nearly perfect babies, and select for various kinds of traits before the baby's even implanted in the womb. What do you think about, A, the likelihood of things like that happening, and B, the desirability of it? In other words, I kind of, when I was pregnant with my children, basically all I wanted was healthy children. I didn't care if they were perfect. I just wanted them to be, healthy. And that even if that didn't turn out the way I hoped it would be, I hoped I'd be capable of unconditional love. Perfect babies and unconditional love don't seem to mesh together in my mind. What is this drive about having, the best and the brightest? Sometimes when I say, gee, I don't know if I want to go in that direction, people will say, like, look, if you're a good parent, good parents use all sorts of ways to help their children get ahead. They give them tutorials, they get gentle work done on them, they might even go for a little bit of cosmetic surgery, they fix their acne, they do all these things. What would the difference be giving them a little genetic advantage? What do you think about all that? I know.
No, that's a huge question. Next time you watch Gattaca,
Yeah.
Notice that in one of the first screens they've got a quote about genetics in the future.
What does it say?
Well, what I remember, the person they're quoting is Will Galen, who's the co-founder of the Hastings Center.
Well,
and a
free advertising.
A very dear friend for very many years. Gattaca is a very interesting film. I mean, it's not a great movie, no. but I think it very accurately captures one possible future. I mean, in Gattaca, they go around with a little vacuum and they get enough DNA to actually do these tests. The same way I can get your DNA from your mug. Okay. That's accurate. I think we can do that today, actually. In the more innocent days, when the World Trade Center, when people bombed the World Trade Center in the early 90s, if viewers remember that, this is before the towers came down.
Yeah. Oh.
The FBI managed to extract enough DNA from the back of the postage stamp, in the old days when we licked postage stamps, that they were able to create a DNA fingerprint, and they identified they linked it to one of the suspects just from that. So Gattaca captured that. Gattaca also captures the likelihood that, if you remember, as I recall, in that future imagined world, genetic discrimination was actually forbidden.
Right.
But of course, everybody did it anyway.
Right.
And I think that's...
on the books, you were prohibited, yeah.
Yeah, that's a part of the future reality that's also potentially out there. The question of what should we do if we had the capacity to know more about the genes of our children, or even to manipulate the genes of our children, I think is, well, it's a question about which I think a great deal. And let me mention just one small piece, and we can continue with it. And that is, right now, most of us we're deluged with information about genes for this and genes for that, and that we're talking about what a scientist would call complex traits or behaviors. And the story basically is misleading, because most of these so-called genes for homosexuality, curiosity-seeking, and certainly intelligence, you get a front-page story, prominent story, then they try to reproduce that result, and they can't do it. And then, of course, that either doesn't get reported in the press or it gets buried somewhere deep in the paper. So most of us probably walk around with the concept that it's going to be easier to use genetic information to kind of predict how our children are going to be than in fact it is right now, or that it's likely to be for a great many years. So the first thing to do is tone down the rhetoric and the hype, and know that the link between genes and complex traits is vastly more complex.
You mean like intelligence and being nice to people and so on and all of that?
Yes.
Some people said, oh, can I find the gene for being more social, or find the gene.
Exactly.
I go like, really? A question I have in relation to that is basically that if people started to try to do this, that the kind of profile they would choose for their perfect baby and so on would just be a reflection of whatever values the culture happened to hold at the time.
Sure.
So we live in a culture that values a certain kind of beauty, a certain kind of intelligence, a certain kind of, way of being. That seems pretty, subject to history. That could change. And then you select in this way, and the conditions change, and are these individuals able to cope in that thing? Another thing I worry about, if people go too far in the direction of perfect babies, how do attitudes change towards people with disabilities, or, people who, for example, what if I chose not to try to have a perfect baby? Would I be irresponsible?
Those are all reasonable things to be concerned about. I've written a lot, as you know, about parents and children and about that relationship. And it seems to me that as a parent, just if everybody could just put aside the science for a minute and just think about what it is to be a good parent, there are certain things that you want to try to control for your child. I mean, you want to, you know, not expose them to horrible risks when they're young. But I think all of us recognize the phenomenon of the over-controlling parent.
Right.
And it comes back at you in a couple of ways. It, for one thing, children become teenagers eventually, and trust me, I mean, if you tried to tighten the screws on them when they were young, they're going to find ways to escape that at some point. Children do need to go through that time when they develop their independence, and so over-controlling early could result in over-rebellion later on and actually doing damage to the child, but particularly to your relationship with that child, which is, I believe, maybe the central relationship in our lives. So that's, you know, over-control has its disadvantages.
Right, and this would just be an
both
example.
for the child and for that, and for your relationship with the child. And the temptations to over-control with genetics are going to be very powerful. They're going to be largely illusory because we're not going to have the control we think we have. The science just isn't there. Right. And what we know about the connection between genes and behaviors indicates that it's going to be exceedingly complex and unpredictable.
Right. You know, going back to the genetic screening, it just occurred to me a topic we've talked about in the past is the development of these so-called gene chips. I wish you could explore that a bit more, where I could find out everything, supposedly, about my genetic profile. Would this be an advisable thing? Like, would there be a lot of pressure on people? You should find out, you know, what you're at risk for. And then you can take all these measures about how you're going to live or not live and so on. Do you think that's a good thing or maybe not so good?
Well, a gene chip it's actually manufactured with essentially the same processes we use to make computer chips. Except instead of ending up with something you stick in a computer or, you know, some other fancy device. In this case, a scientist or a clinician would use it, would take a little sample of your blood probably, would treat it, run it across this chip, and the chip will give you readouts and tell you whether you have up to, the last I heard they had at least 500,000 different data points on a chip, and I'm sure it's well beyond that now.
500,000?
Yeah, 500,000, and it's probably going to be 1 million or 2 million. It's probably there by now. So you can get in from 2 million different data points about your genome from a single run on a gene chip.
That
and
seems
it's going to
like
get
too much information.
Well, it's going to get cheaper and faster, and you're going to get, you know, the information density is just going to continue to explode.
This is going to go to my doctor.
Well, so that we know you can get that. What does it mean?
Right. What does it mean?
What does it mean? Well, that's a whole lot more difficult to do. I can give you the data. What I can't tell you is what it means for your health now, or for your health in the near future, or even for your health in the far future. That kind of information is going to be much more difficult to come up with. Now, ultimately, we will be able, the hope is, we'll be able to link the results on one of these gene chips and be able to say to somebody, well, you are at especially high risk of heart disease. And so we'll hope that we'll put you on a diet, we'll start you on an anti-statin, and we'll try to get you to exercise. Will that make a difference for you?
Maybe my insurance won't cover me.
Well, if we continue with the current system of this kind of patchwork of insurance programs, yeah, you might be out of luck. Or the insurer may say, we'll cover you if you've just come up with this test and you're at high risk of heart disease. We'll cover you if you break your leg or develop cancer. If you get heart disease, it's been nice knowing you.
Oh, yeah, those are the kinds of things I worry about. You know, if you had one take-home message to our audience out there about us, are we more than our genes? What would you say to them?
Well, the metaphor I used in congressional testimony
That sounds heavy, okay.
20-some years
Yes.
ago, was that the genome is rather like the score of a piece of music. It's the notes written on the paper. But of course, each of us is not just the notes on the paper. Each of us is the performance of that score. And there's so much in the translation from the notes to the actual performance. And so, you know, there are almost an infinity of different ways of translating those notes into a performance. And that's what we're like. But except the difference is we are the conductors and the musicians of our own performances, of the symphony that is our genome.
Yeah, I mean, that's one of the messages in Gattaca. It's about somebody who really didn't have the perfect genetic makeup, who basically says, I'm going to defy that fact, and through my spirit and through my resolve, overcome certain obstacles and do what I dream about. And he proves it, and he does it. So I think that's what your metaphor is basically saying. I don't think I've ever heard a better metaphor for what our possibilities are. Do you think we're in danger socially of a certain kind of genetic reductionism where we forget that we're more than just the score?
Well, that is the danger of this sort of overenthusiasm about genes as explanations, particularly of the things that we regard as morally important about human beings. And the science just doesn't support. I mean, it's not just an ethical issue; it's a scientific issue. This is as much bad science as it would be bad ethics to assume that genes explain things in that way. So that's, I think, the big challenge is to draw back, say genes are part of the story, but only a part of the story, and not as big a part as we may sometimes think, and continue to take responsibility as the authors of our own lives.
Yeah, I think that's really a powerful take-home message for our audience, that we still have to believe that our free will and our spirit and our spunk basically help shape our genetic conditions and so on. Tom, it's really been great having you with us today. We really appreciate everything you're doing through the Hastings Center, and also now here in collaboration with the university and My Ethics Center, the Bioethics Resource Group, and the Mecklenburg Medical Society, to basically get this message out to the public about not being overly enthusiastic about the genetic information, but to take it into account in their calculations and so on. So thanks for coming to Charlotte. We really appreciate having you here.
Thank you, Rosie.